Using this formula right here, we are going to show that the slope of this function at 4 is 8. So we're going to say our function is x squared. The x we're concerned with is 4, and we want to know what the slope is. We want to know the instantaneous rate of change at 4. You guys okay? All right, we're going to do some algebra here. Here's what we're going to do. We're going to start with the limit as h approaches 0 of f of x plus h minus f of x over h, which is our limit definition of the derivative. We're okay? Now, that's going to be our first step. So, in fact, I'm going to write them as steps. Step 2, here's what we're going to do. We are going to sub out f of x, and we are going to sub in what f of x is equal to. What is f of x equal to? And that's right here. F of x is equal to x squared. So what we're going to do is we're going to sub out f of x, and we're going to put in x squared. Are we okay with that? All right, now, here, do you see this? I need to show you something. Do you see where it says f of x plus h? I need you to understand that if you, let's say that you had some arbitrary function that said 2x to the third power, right? And let's say that you wanted to know what f of x plus 9 is, right? Here's what you would do is you would rewrite the function, but instead of writing an x, you would write x plus 9 and then put it to the third power. Do you see what I did here? Do you see that? That's called a composition function. Here, what can I sub? If I sub out f of x plus h, the limit as h approaches 0 of, instead of f of x plus h, what am I going to put here? Yes, x plus h squared. There we go. Yep. X plus h squared minus x squared over h. Nope. We're taking the function notation out and putting the function in. Okay? I'm waiting. I need you to understand that f of x plus h, if f of x is x squared, then where I see an x, I put in an x plus h. If I replace this x with an x plus h, what will it say? It'll say x plus h squared. Correct?
So you just add that other variable and put that.
Something like that. Yeah.
What is that called?
Now, it's a composition function. In fact, I recommend looking up composition functions. They're really easy. Now, watch this. Equals, this is now equal to the limit as h approaches 0. Okay. Does this look familiar to anybody within the past week?
Yeah, it does.
What does that look like?
Oh, expand.
Yes. And what do we have to use to expand this? The binomial theorem. That's correct.
Oh, just make it connect.
And what does this expand into?
It's going to expand in
X squared. Wait, x squared, say again, plus. Close.
Oh, no, plus
2xh plus h squared. Very good. All right, so look, we do the binomial expansion here, right? So we got this. Now what do we put on? Minus x squared. That's correct. Over h, right? But before we cancel the x squared, I want to go ahead and put our 4 in. Okay, because we're going to cancel it. I want you to remember what you just said in a week or a week and a half. Okay? So watch this now. We're going to go ahead and put our 4 in now. So now we're going to have the limit because x is equal to 4, right? So we're going to have the limit. And by the way, you could have put the 4 in up here. I know you guys are accustomed to doing the binomial expansion, the binomial theorem with letters. All right, so the limit as h approaches 0 of, what's 4 squared? 16 plus, what's 2 times 4? 8h plus 8h plus h squared minus, what's 4 squared? 16 over h. Good. Now what is 16 minus 16? Right? 0. They cancel each other, right? And so now what we have is the limit as h approaches 0 of 8h plus h squared over h. Nope. We can cancel an h.
On both sides?
Yeah, well, look. Look at the numerator. Can't we factor out an h here? Can't we? Yeah, so this would actually become h times 8 plus h, right? Now, algebraically, can I cancel an h? Yes. What is remaining? 8 plus h. Now, once I cancel the denominator, y'all have done limits before, right? When we cancel the denominator, don't we then go back and plug our number in to see if it gives us an answer? So can I plug 0 in here now? And what is 8 plus 0? Here's what we just figured out, folks. We just magically identified the slope of a curve, not a line. We identified the slope of a curve at a single point. We just identified the instantaneous rate of change of x squared at x equals 4, and that slope is 8. Why don't we do, except we're going to change the function up. Let's make it x squared minus 5. Let's make the function x squared minus 5. We are going to replace these two with that function, right? So we're going to have the limit as h approaches 0 of, let's see, x plus h squared minus 5, right? Minus, now watch what I got to do here. I got to actually use some brackets. Minus x squared minus 5. Now I don't have to use brackets, but if I don't use brackets, what do I have to remember to do to this minus 5? I make it plus 5. I got to distribute the negative, right? I'm subtracting x squared minus 5. So what has to happen to this? Has to turn into a positive. So if I take the brackets out, I have to change this to a plus 5. Right? Over h, right? So now let's go ahead and work out our x plus h squared. So we'll have the limit as h approaches 0 of, what's this going to become? X squared, yep, 2xh plus h squared minus 5 minus x squared plus 5 over h. And yes, you can cancel things. By all means, do so. Yes, sir. The function is now x squared minus 5. So when I replace these functions, I have to put the whole function in. The whole function is x squared minus 5.
Oh, it's just that you put the x and the h together and then...
Yeah, because here's what you do. Watch this. All right, let me do an aside here. Yeah, let's say that my function, let's say that I have some function that is 7x to the third power minus 9x squared plus 4x minus 3. And I want to know what f of x plus h is, right? So look, everywhere you see an x, take the x out and put in parentheses with an x plus h in it. So this would be 7x plus h cubed minus 9x plus h squared plus 4x plus h minus 3.
Oh, I get it. So
Yes.
once you see an X, you just...
Anywhere you see an x, put in an x plus h. That's how composition functions work.
Everywhere you see the X.
That's how composition functions work. So now, here, what am I going to plug in for x?
-2.
-2, because x is -2, right? Okay? So what's -2 squared? 4. Yes, we can, but yes. Okay, fine. We'll cancel this, we'll cancel this, we'll cancel this, we'll cancel this. And now there's an x, and we got to put a -2 in. So now we have the limit as h approaches 0 of, what's 2 times -2? So -4h plus h squared over h. Take out an h, so we'll cancel an h in each term. And now we plug 0 in for h, and what do we get? No. Well, yes, we have negative 4 plus h. Now, solve the limit. Put a 0 in for h. Negative 4. That's your final answer. So the slope of that function at negative 2 is negative 4. Step 2. What am I going to write in here? You know what? Let's do this. Let's go ahead and... well, let's... All right, so the limit as h approaches 0, right? All right, what am I going to put here?
You're going to put
4 parenthesis
x plus h
x plus h squared plus, nope,
X plus 8.
x plus h. Now, well, look, everywhere you see an x, we have to put it in an x plus h. We got an x here and an x here.
Yeah.
Both of them have to get an x plus h. Right? It's okay. We're good. Minus what? What is f of x? Correct. But watch what I'm going to write. I'm going to write 4x to the second power minus x.
Okay.
Because I distributed the minus, right? We're subtracting this whole function. Therefore, I have to subtract this and subtract this. I have to distribute the negative. Correct? All right? All over h, right? And now, let's do our, I'm going to write it down here now. I'm going to go vertical instead. So now we're going to say the limit as h approaches 0 of, what's this going to become? What's the binomial theorem here? Well, let's do this first. Let's just do the x squared plus 2xh plus h squared, right? Now, right.
Plus 8x squared plus with 4h squared.
There we go. So we did the binomial theorem and distributed the 4. So now we have 4x squared plus 8xh plus 4h squared. Plus what?
Oh. X
Plus x
plus 8.
plus h minus 4x squared minus x all over h. Now we cancel stuff, right? We have a positive 4x squared and a negative 4x squared. So those can cancel. We have a positive x and a negative x, so we can cancel those. And now, where do we have to plug in our 3? Where am I going to put the 3? Because x is equal to 3. And there's only one. So this is going to become what? 24. So now we're going to have the limit as h approaches 0 of 24h plus 4h squared plus h over 8. Well, let me finish writing it. There we go.
No, I was talking about when you, you plug
Yeah.
in the 3. I was talking
Yeah, plug the 3 in.
where does 4 come from?
Yeah. So I got 24h plus 4h squared plus h. Now I'm going to take an h out, right? All right. Well, what that's going to do is if I cancel this h, I'm going to cancel an h here and one of them here. So there's still going to be an h there. Now, what's this h going to turn into? 1. It's going to turn into a 1, right? So now I have 24 plus 4h or 4h plus 1, right? It'd be 25. So when I put the 0 in for h, this 4 times h is going to become 0, and I'm going to have 24 plus 1. Because of this h up here. Yeah, when you canceled this h out, it becomes a 1. H divided by h is 1. Right? And so the final answer is 25. Let's ramp it up, shall we? How about this? Let's do 2x to the third power minus 5x squared plus 4x minus 1. That's it. You just need to know where everything goes. All right, let's say that x is equal to 2. Say that x is equal to 2. All right, now, I am going to make it a little easier for you. This time, what we're going to do is, this is an important step, okay? This time, what we're going to do is we're actually going to plug the 2 in here first so that we can write less stuff down. Okay? So what if we plug 2 in, what is f of 2 here?
8.
F of 2. Yeah. So f of 2 is 3. Right? So now watch this. So now watch what I'm going to write. I'm going to say the limit as h approaches 0 of 2 times x plus h cubed minus 5 times x plus h squared plus 4 times x plus h, okay, minus 1 minus f of 2, which is 3. So I'm going to put a 3 here. See that? My little shortcut? And you can do that on all the problems if you want. And if you want to, what is minus 1 minus 3? Hang on. Negative 4. So really, we can just put minus 4 here. There we go. Minus 4. All over h. Now, what's this going to become by the binomial theorem? It's 1, 3, 3, 1. So x to the third plus 3 x squared h plus 3x h squared plus h to the third, right? Okay, then, right, but now let's distribute the 2. Is that okay? We're going to distribute the 2 through here. So now it's going to become 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed, right? Excellent. So now, x squared, this one becomes x squared plus 2xh plus h squared, right? And we're going to distribute a negative 5 to it. So it's going to become minus 5x squared minus 10xh minus 5h squared plus 4x plus 4h minus 4 all over h. And it's the limit as h approaches 0. See? Yes. Oh, absolutely. Absolutely there's a shortcut.
Where is it?
I'm going to teach it to you next Thursday. And you're going to be so thankful to have that shortcut that you're going to remember the shortcut. Because for 7 years I've been teaching AP Calculus, and for all the students where I just hand them a shortcut, here's a shortcut, here you go, now you know how to do it.
They get it.
3 months later, they're like, what was the shortcut?
Oh, no, I'm going to remember this.
Oh, you are going to remember the shortcut.
This is
After doing this, oh, you're going to remember the shortcut, all right. Yep. Yeah. I'm not kidding you. The shortcut is the easiest thing. I could teach a first grader the shortcut.
Is it
Okay.
an easy shortcut to find?
Well, we're getting
What
there.
if I go home and find it?
Oh, absolutely. Yeah, you can go home. How do I find the derivative of a polynomial function?
I don't want to look it up.
Exactly.
I
You
wanna
wait for it.
find
Yes.
No, what if I find the shortcut?
Oh, that's fine. Yeah, figure it out.
Will you give me ice cream?
No, but you will give you learning. Listen, the best rewards are not rewards. The best rewards are the positive consequences bestowed upon us by the universe for us seeking without relenting. So when you search, when you want to understand and you learn and you understand something, you have been rewarded. Similarly, the most effective punishments are not punishments. They are the negative consequences for us making decisions that are not good for us. Watch. Now, don't hate me for this, but here's what we're going to do. I'm going to go through it. If you want to go back and watch a video, go back through and watch a video. But watch this. We need to now put 2's in for all the x's. Okay? All right, so look. This is 2 to the third power. That's 8. Right? Times 2 is, so this now becomes a 16. Okay? This is 2 squared is 4 times 6 is 24. This x times this 6 is now going to be a 12. There's no x's here. This is 5x squared, so this is going to be minus 20. So this can be minus 20, right? This 10 times x, that's going to be a 20. Okay? That's going to stay. There's no x's there. 4 times 2, that's going to be an 8, right? and then there's no x's here. So now here's what we have. 16 minus 20 is negative 4, plus 8 is 4, minus 4 is 0. So all the constants cancel out. So we canceled all the constants. Now, and all the x's are gone. So now we only have to deal with h's. So now look, cancel an h out of every term. Cancel h, cancel h. Here we're only going to cancel one of the h's, and here we're only canceling we're only canceling one of the h's, so this is h squared. Here we're going to cancel an h, here we're going to cancel one of the h's, and here we're going to cancel an h. Okay? Now, anything that still has an h is going to become 0. Because now we're going to plug 0 in for all the h's, right? So this is going to be 12 times 0, right? So that's going to cancel. This is going to become 2 times 0, so that's going to cancel. This is going to become 5 times 0, so that's going to cancel. And all we have left is 24 minus 20.
Where'd you get?
Oh, sorry. Where's the...
Did you miss it? You're missing a...
No.
Minus 20. That 8 got canceled. Plus 4,
Which is still 0.
which is 8.
Oh, no, wait.
We did all that for 8.
No, we did all that for the answer. Did you want the answer to be 5,000? What did you want the answer to be?
Something meaningful.
So what you're telling me is that 8 is not meaningful.
I didn't really like
Don't
it
be
when I was
great
8.
at 8 like that.
That's what I'm talking about.
When I was 8.
7, 8, 9.
Don't degradate.
Mr. Ryan, no, leave the room.